Hi, I'm just going to do an example of a distance from a point to a line, and I'm going to do it two ways. So the way I did in the other lecture, and then I'm just going to do it a little bit easier. I thought of a better way that it might be less confusing. A lot of people are having trouble with it. So I've got an example here. Thanks to a student in a class, we've got a point and then we've got a line, and this line is given to us as 2 points. So what we have is some point, and it doesn't matter if this is drawn accurately, and then a line through 2 other points, say A and B, and what we want to find is the distance from this point to the line, and what they mean is the shortest distance. So that perpendicular, the length of this is what we're looking for. So we can't really find that right now because we would need this point, let's call it C, and we don't know what that point is. But if we did know this point C and we're given this point 0, 2, 2, then we could subtract them. That gives the vector in between, and then you find the length of the vector. So that's essentially what we want to do. And we're going to do this 2 ways. I'm going to show you the shorter way first, so a different method, and then I will show you sort of the longer way that uses projection. So the first one is actually not going to use projection. So first, let's take the line and let's write it in a different form. So if we want the line through A and B, let's say we find the vector AB. So that is take B, whoops, and subtract A. So -1 minus a -4 is 3, and then 3 minus a -1 is 4, and 1 minus a -5 is 6. Okay, so we could write this line as a point, so one of the points, -1, 3, 1, because they're not negative, plus the direction vector, we just found 3, 4, 6. So what that means is that any point on the line is of the form -1 plus 3t, and so on. So the y value would be 3 plus 4t, and the z value would be 1 plus 6t. So this is the parametric equation. X is -1 plus 3t, y is 3 plus 4t, and z is 1 plus 6t. So both the point A and the point B would follow this sort of pattern. There'd be a value of t that I could plug in. If t is 0, for example, then we get the point x is -1, y is 3, and z is 1. So that's this point. Which one was that? B. And if we wanted to find the point A, I could do that as well by setting x equal to, and this is just kind of off to the side, this isn't part of the question, but if I set x equals to -4, I could solve for t. So t is -1. So if I plugged in t is -1 into each of these, I get x is -4. I would get y is 3. 4 times -1 is -4 is -1. And z should be 1 plus 6 times -1, which is -5. And so you see that if I plug this value in, I get the point A. And all different t values plugged in would give me a point on that line. So I could plug in different t values. I am interested in one specific t value though, and that would be this one that would give me C. So how would I do that? Well, I want you to think about this. I have a line right here, and this one is perpendicular. And what I know about perpendicular lines is that their dot product, if I have those 2 vectors, their dot product is 0. So what I could do here is I could say, okay, well, C is some point on the line. So let's say, whoops, let's say C is a point on the line. So it would follow the form -1 plus 3t, 3 plus 4t, and 1 plus 16. Remember, that's any point on the line has to follow this pattern. So for some value of t, I don't know, but we could find that. So that would be the point C. And we know this vector, or vector in this direction. And if we knew this vector, we could do the cross product, or the dot product, sorry, and get 0. So how does this look? So see, this is a point on the line. We want the exact value of t that is this point at the end. So let's say our point P, which is a 0, 2, 2, is at the other end of that. So if I said we wanted to find let's say PC, so we would take C and subtract P. So the first one would just be the same, P, or C subtract P, this one's -2, and the last would be this. So let's just summarize this, -1 plus 3t, 1 plus 4t, because that's 3 minus 2, and the last component would be -1 plus 16. So this is the vector that we want the length of. But we really need that value of t. And so PC should be, if we do the dot product with the AB, did I call it AB? AB, should give me 0 because I want them to be perpendicular. So AB 3, 4, 6, I found that is the vector in that direction. So I want to do the dot product. With 3, 4, 6. So you would multiply this times 3, so -3 plus 9t, add to it the second one, so 4 plus 16t, and then add to it the third one, so -6 plus 36t. And that whole thing should equal 0. So -3 plus 9t plus 4 plus 16t minus 6 plus 36t should equal 0. So let's say 9 plus 16 plus 36 is 61t. And then we have -3 plus 4 is -5 equals 0. So 61t equals 5, or t is 5/61. So if I plug 5/61 in, that will give me the point on the line that's perpendicular. So remember, every value of t gives me a point. So if I take my equation of C, that point, I'm just going to rewrite it here. And if I plug in 51 or 5/61 plus 4 times 5/61 and 1 plus 6 times 5/61, we will get the point. I think I worked it out earlier. I did. Not. Well, I don't see it. Okay, so minus 46 over 61. Oh yeah, I did. I saw that. 203 over 61 and 91 over 61. Okay, so that's the point. So if I just redraw what I had, remember I had a point P here. I just found the point C here, which is perpendicular to the line with A and B on it. And every point on the line, we found an equation, a parametric form. So what I found was these 2 points. Now, if I know the point P, which is 0, 2, 2, that's right here, and I know the point C right here, I can subtract them and then find the length. So subtract them to get the vector between it, and then I can find the length. So let's say we do, it doesn't matter which direction we subtract them. So minus 46 over 61 minus 0. Uh, 203 over 61 minus 2. And 91 over 61 minus 2. Find those numbers and then find the length of that. And I worked this out earlier and I got 1.61. So that would be whatever the units are, 1.61 long. Okay, so that's one way to do it. So let's recap. I was given 2 points on a line. A and B. I subtracted them to find the vector. Of the line. Then I wrote the line in parametric form. Right? That was x equals y equals z equals, which is an equation of any point on the line. So then I use that to say, well, that is C with some t plugged in. We were given a point up here, and this is what I was looking for. So what I did was I found this vector. I think I did PC. I subtracted them. This had like a general equation that I found over here. And I took that, which was sort of an equation, and then I took the line. So I took PC and I did the dot product with AB, which would give me that perpendicular vector, and then that was used to solve for t. I took that t value to find the point C. And then I knew P and C, so I can find the vector between them to find the length. Okay, and that's what I did. So yeah, with a slate. Yeah, that's right. PC, I did the dot product. That let me find the point C. Then I took those 2 points, subtracted them, and I should have really done it the same way. Yeah, PC, and then I did PC here, and I got the length, which is 1.61. Okay, that I think is the easier way. Now in class I did projection method, so we're just going to look at that too. It's a little bit longer, but you do end up with the same answer. So if we were given the point 0, 2, 2, and the line through A, which is -4, -1, -5, and B, -1, 3, 1. Okay, So we're going to do the same question. So I have a point here, and then I have a line with A and B, and some unknown point here, we'll call it C. And what I can do here is find, so find the direction AB, okay, by subtracting those. And so AB is 3, 4, 6. We did that earlier. Okay. And then what we can do is say, if I know, so this direction, it's maybe not the right length, but I know that direction is AB. I can find this vector. Let's call it BP. And if I know this vector, this exact vector between the 2 points, I can take the vector AB, which is this one, and if I project, do the projection of BP onto AB, what I will get is this part right here. Okay, so that would be the projection. Now that's not what I want, because what I actually want to find is this distance right here. But if I know 2 sides of the triangle, I can find the third. Okay, so that's the idea. This is what we actually want to find. Okay, so let's go ahead and do that. So we know AB, and that's what we're going to project onto. AB is, not necessarily the vector we want. C is somewhere, on that line. And it might be with this drawing, it could even be in the opposite direction. We don't know. Okay, that doesn't really matter because the drawing itself is just to help you visualize what it is we're doing. So if I found BP, so P, is 0, 2, 2. So 0 minus a minus 1, 2 minus 3, and 2 minus 1. So 1, negative 1, 1. So there's BP. So now I will take that, and to do the projection, we do BP dot with AB over AB dotted with itself times AB. And this will give us the portion of AB that we want. So BP dotted with AB. So 3 times 1 plus 4 times negative 1 and 6 times 1. So 5. And then AB dotted with AB. So AB is 3 times 3, 4 times 4, and 6 times 6. That's 61. And you might recognize that 5 over 61 is the value of T that we actually found earlier. 5 over 61. Okay, so you're noticing that, yeah, that we're on the right track here. So this is 5 over 61 of AB. Okay, so what does that give us? That gives us this green vector, this part. Okay, so it's saying that that's the length, and we kind of can guess that that's probably true from our calculation earlier. We had that same sort of 5 over 61 factor. Okay, so what do we do with that? Well, we need to find the point C and then the length, just the same as we sort of did before. So if we want to find C, then we can do that by saying that this point is like an X, Y, Z. We don't know it. And this point is B, which is, what's B? -131. Okay, and so if we wanted to find the vector between those, let's say B is -1 minus x, 3 minus y, and 1 minus z. So that's that vector. And it should be equal to the vector we just found, 5/61 times 3, 4, 6. So let's just multiply this out to get an actual vector. So 5 times 3 is 15/61. 4 times 5 is 20/61. And 6 times 5 is 30/61. Okay, so we found that vector when we did the projection, and then if I subtract those, I should get the same vector, and then if I set these equal to each other. So -1 minus x should equal 15/61. So x would be -1 minus 15/61. Which is -46/61, same point we found earlier. Y minus 3 minus y equals 20/61. So y is 3 minus 20/61, which is 203/61. And z is 1 minus z equals 30/61. And if we solve for z, we get 91/61. This is the same point we found earlier. And so in the same way we did earlier, we find the vector between P and this point C. And then the length of it. And then if we do the length of that vector, we get 1.609, or 1 in the same answer we had before. Okay, so sort of two ways to do it. This second one, you have to just be careful at one step, which I find is where I sort of get messed up when I do it, is at this step. When you set those equal to each other to solve, this is sort of where I mess up, because I sometimes will do this one backwards, and then you end up with slightly the wrong points because you're not going to the exact place you want. But maybe the dot product way you like better, and you can do it that way too. And there's probably other ways that you can find this, but the key in both of these methods is finding this point C and then subtracting the two to find the vector between them.